Everyone, my name is Leo. This is for TSM 435. This is for lab 6. This is for our online ballistics lab. The goal of this lab is pretty much just to get this output from our lab. After adding, this is what we have right now. After adding all the components, the axes, the buttons, the edit fields, so on and so forth, we should get something similar to this. All right. So the idea pretty much is that, given certain variables such as projectile density, mass, diameter, elevation, height, speed, drag coefficient, air density, gravity, given those variables, all on SI except the elevation, of course, given those variables, we should get some sort of output, given those inputs, rather, we should get some sort of output, which are max distance, max height, terminal velocity, impact velocity, and airtime. This is pretty much going to be a straightforward calculation. Calculations is done in the program, but basically, there's some formula that you take some of these inputs to get the output, and based off of those outputs, we should be able to graph the graph as we've seen before. So let's just get right into it. So let's start here. These are pretty much just our components that we added before. The edit fields, the axis, so on and so forth. These are our properties right here. You have your elevation angle, your mass of the projectile, the density of the air, projectile diameter, stuff like that. These are the same things. These are our inputs, but these help us actually make the inputs into a variable in the program. Again, this is our initial projectile velocity in the X and Y direction. You use the app.v right here because we've actually made it into a variable. We need sine and cosine because that's how the math works, and we need our elevation to see how high it goes. This is a frontal area particle. This is important because depending on the frontal area, it'll go at different speeds or velocities, I guess. K is based off of this right here that we're going to need to solve our Reynolds number. This is where we define initial conditions. So again, our graphs are going from 0 to 10,000 here. We need to define some sort of initial condition. We're going to be using this program right here, this other MATLAB file to help us. Finding the X where Y is less than 0. So this is basically where when the ball hits, when the cannon hits the ground, we have at what X distance does it impact, at what Y distance does it impact, the same for velocity and time. Basically when time is equal to 0 is what we get over here for our X's and our Y's. And again, the total is just right here. Just add them up and the square root. And then we have a Reynolds number right here. This formula right here. So this is our linear interpolation of line distance. This is basically where we have the outputs that we have over here. This is basically where those calculations come from. Max height is just max distance at Y, where Y is max, obviously. For your impact, just square root of X to the power of 2 plus Y to the power of 2, so on and so forth. And then here, so we give our edit field these values. So when we press go, the edit fields output those numbers that we calculated. This is for our 3 graphs. We did the trajectory plot or axis in class, and the other ones, the speed, the velocity, and Reynolds number, they're just a carbon copy basically. You change obviously we're not doing a trajectory axis anymore, we're doing speed axis, and you might have to change a couple things here and there, but these are essentially the same. You have your labels. You want your X label, your Y label, your height, your distance. You need the grids. You need your limits. You can't go from 0 to infinity. We don't have enough space for that, so we need some sort of limit. And here's the legend that we did before, that we had to do. So here we're gonna go from here to here. Now let's check it out. So I press go, given the numbers we had in class. It takes a minute to load. Oh, I'm sorry, I press go. You press run. So now we have this. I could change these inputs, but I'm not gonna. I'm just gonna go for it like this. Bam. Bam, 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 and bam. And as you can see, these are max distance, max height, terminal velocity, and so on. Thank you very much.